Hey sixth graders, you are now in station 1, so we are going to quickly go through our mini lessons. You can watch this video and then afterwards all the slides that we are going to look at are going to be behind this one, so you can click next to kind of go through them if you want to reference anything. Remember that you will be filling out your notes as we go through this lesson, so you can either do it while we go by having your screen split side by side, or you can come back and do your notes after. So let's get started. So today we will be able to identify the relationship between electricity and magnetism. So we've talked about electricity, we looked at electric circuits, we kind of looked at making open and closed circuits using different materials that are either conductive or are insulating. So now we are going to talk about magnetism, and then we're going to talk about the relationship between electricity and magnetism. So we're going to mix both those things back together. So if we look at this fridge here, what do we see? What do you notice? I'm just going to give you 20 seconds to think about what you notice about this fridge. So you might see here some magnets on your fridge. Have you ever used a magnet on a fridge? Have you ever used a magnet on something else? What makes something a magnet and what attracts them together? That's what we are going to continue to learn about. So electricity and magnetism. Electricity and magnetism are super closely related. They are both caused by negative and positive charges in matter, and when charges from one piece of matter interact with those of another, then they produce this electric and magnetic forces. So electricity can produce magnetism, and magnetism can create electricity. All right, a magnet is any material that attracts iron. All magnets have a north pole and a south pole, or a negative pole and a positive pole, and those poles are the regions in the magnet where the magnetic force is the strongest. So it's where the magnetic force is really going to be super strong and allow those things to attract or repel each other. So when I pick up a magnet and I try to pick up some paper clips with my magnet, what's going to happen? They're going to be attracted to my magnet because there are some iron, there's some iron in a paper clip. So let's visualize this for a minute. If you sprinkle iron fillings around a magnet, so if you take some iron fillings and sprinkle them on the ground, then you take a magnet and put it over the top, then those magnetic fillings, they will start to line up and kind of attract to that magnetic field. The lines that you see when this happens is called the magnetic field lines. You will notice this in this picture here, and then if you've ever played with one of these woolly willy things, you can that's what that's filled with. It's filled with those little iron fillings, and then you can kind of pull your magnet around to kind of move it around and give him some hair and give him some funny faces. Likes repel and opposites attract. So the north pole of one magnet is attracted to the south pole of another magnet. So opposites. So the north and south are opposite and they are attracted to one another. If I have two norths, then they're going to repel each other. Remember when we talked about repel, like that bug spray, they want to go away, right? If I have two north poles, they're going to repel each other. If I have two south poles, they're going to repel each other, but if I have a north and a south, then they will attract one another. So we can look at this example here where our north is showing as blue and our south is pink, and again south and north, and these are repelling each other as well as the north and south ones in this example. And then in the next example they are trying to attract each other, the north and the south together. So a magnetic field is that area around the magnet that is affected by the magnetic forces. So it's all that area here that you see around it that's affected by these magnetic forces coming from this magnet. And our Earth actually is a magnet. So in our core, our outer core of our Earth, we have a magnetic field around it, which is why our things like our compasses are moving and they work because the magnet in our compass is attracted to the magnetic pole of the Earth. Electromagnetism is the results when electric currents and magnetic fields, they interact with each other. So that's the relationship between electricity and magnetism. That's where they come together. So electromagnets are something that we use in electric motors and other devices from loudspeakers to televisions to doorbells. So we use electromagnets in our electric motors to use some of these things that we use all the time. How can we make a magnet using a current? So we've talked about a current. We know that we can create that current, or our charge allows us to have that electric circuit work. So how can we make a magnet using a current? So a coil of a wire that carries an electric current also produces a magnetic field is called a solenoid. And the more loops that we have in our coil, so if we look down here, this is our coil, all the wires spun together is called a coil, the stronger the magnetic field we have. And when we attach it to a battery, then we can add something and turn it into a magnet. So if we wrap that coil around an iron core, something with an iron core, or something that's made of iron, then we make that electromagnet. And that combines our magnetic field and our solenoid with the magnetic field, and it makes our iron core magnetized. So it can actually pick up things that are made of iron because now it is magnetized. So the more loops that we add increase the electric currents, and it makes it stronger in our electromagnet. So if we have just a few, we might not have it as strong as if we had a lot of them. So what do we use electromagnets for? What are some of the things that we use it for? So electromagnets are used in many devices that we use every day. So we use them to make our doorbells ring. We use them in really big electronics to move heavy metal. And we use them in small electronics like our hair dryers and our speakers. We also use them here in MRI machines, and we use them in big things. So we also use them for electric motors, which they change our electrical energy into mechanical energy. So remember when we talked about forms of energy. So electric motors, they range in sizes from largest things to small things. We can power Ferris wheels, and we can use these devices to power our motors, to have a motor. So we also have simple motors, which are, again, they have coils or loops of wire together, and they become an electromagnet when current passes through them in a different way. In this example, the armature rotates because the poles are pushed back and forth by the opposite poles of the magnet. So you can see that there is a little magnet here that is causing the armature to rotate because it is being pushed and pulled by the opposite poles of the magnet. It will turn until its north pole is opposite of the magnet's south pole, and then it's going to keep turning. We are going to make one of these later in one of our stations, so I'm going to leave this for you to continue to explore. All right, don't forget that you need to fill in your notes back on your page and have a great experience in these stations. Happy learning!